In this video, I'm going to show you how you can solve problems regarding the concept of powers, roots and standard form, and I show you how I use my methodology to solving these problems, and hopefully this helps figure out your methodology to solve problems regarding to these concepts. So let's jump straight in with the calculator intro. So if I open this link from Save My Exams platform, and the topic is numbers and number system, and the subtopic is that we are going to focus in this video, and the next subsequent video is powers, roots and standard form. So if I open this in a new tab, so these are the concepts. So let me just give a brief explanation of powers and roots. So what are powers? Powers is basically a repeated multiplication of numbers. For example, 2 to the power 5 means 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. So 2 multiplied 5 times is 2 to the power 5, and roots is the inverse of the power, which is the fifth root of 32 is 2. So for more explanation you can look or research into the concepts of powers and roots. So I'll focus on the problem solving. So I'll focus on the medium level. So let's start with the first problem. What does the first problem say? So the first problem says one sheet of paper is 9 multiplied by 10 to the power minus 3 centimeter thick. So Mark wants to put 500 sheets of paper into a paper tray of his printer. The paper tray is 4 centimeter deep. So is the paper tray deep enough for 500 sheets of paper? So if I open a new tab, the question says that the one sheet of paper is 9 multiplied by 10 to the power minus 3 centimeter thick. So there is a sheet of paper that is 9 multiplied by 10 to the power minus 3 centimeter thick. So there is a paper tray. So let's say this is a paper tray. This is a tray, like a tray, and this tray the tray has like a maximum height of 4 centimeter. That's what's given, right? So the paper tray is 4 centimeter deep. That means the height or depth is 4 centimeter of the paper tray. So how many piece of papers can it have? Like, can it have 500 sheets of paper? That's the question. So you have to explain. So in order for this tray to contain 500 sheets of paper, let's check whether it can contain or not. So if the depth is 4 centimeter, how many layers can we have of 9 into 10 to the power minus 3 centimeter thick papers? So if I divide 4 by 9 multiplied by 10 to the power 3 centimeters, so we can get the calculation. What is the calculation? If I take this here, it will be what? 4 multiplied by 10 cube, 10 to the power minus 3 will become plus 3, divided by 9, or this is also what? 4000 by 9, 4 into 1000, or 4000 by 9. So can 4000 by 9 result 500 or less? So let's check. If I use my calculator, let's just divide 4000 divided by 9. So it has 444, roughly 444.4. So it cannot contain 500 sheets of paper because it's less than 500. So this is the solution to this problem. So if I now focus on problem number 2, what does the problem number 2 says? So it says you have to write the following numbers in order of size. So there are 4 numbers given with appropriate expressed in powers. So you have to write them in order of size. So from the smallest to the largest. So let me go to my notepad and use my pen tool and write those numbers. So in this form, let's just first write this number in this form. So what is the first number? 0.038 multiplied by what? Multiplied by 10 square. Okay, so this is the first number. And what is the second number? 3800 multiplied by 3800 multiplied by 10 to the power 4. So if I look at the first number, what is the first number expressed as? So it's represented in the float number and multiplied by 10 square. Okay, so this number, if I multiply by a positive power, then then you have to shift the point from because there is power 2, will shift the point to here. So it will be what? 0.03 multiplied by 10 square is 3.8. This is what it is expressed without powers. So what is 3800 into, it should be 10 to the power minus 4. So what is 3800 multiplied by 10 to the power minus 4? It is, if the power is minus or negative, then the point from the right is shifted according to the power. So if the power is minus 4, then it will be shifted from 4 places from the right. So 1 2 3 4 4 places. So it would be 0.38. This is the result. So in case of 380, it's represented as the number without powers. Okay, so if I look at the fourth number is what? 0.38 multiplied by 10 to the power minus 1. Because the power is minus 1, will shift it to the right. So one place, because it's minus 1. So the result would be 0.038. So now we have a clearer idea of what is the smallest and what is the biggest. So what is the smallest in the 4 numbers? Of course 0.038. So this will go in the first. We'll start with 0.038. This is the first number, the smallest number, and then we'll have what? 0.38. This is the second smallest number, 0.38, and then it's 3.8. then it's 3.8. the 3.8 will come here, so it's 3.8, and then this is the second largest number, and then the largest number is 380. So this is how you can order numbers which are expressed in powers, like expressed in powers of 10. So this is how you can represent the numbers from smallest to largest in the only floating point without powers. So now we'll focus on solving problems regarding the concept of roots. So if I go to medium category and problem number 4, which has 2 parts, 4a and 4b. So these 2 problems are regarding the concept of roots. So the problem 4a says, write down the value of the number 100 to the power half. So what is to the power half? So if I go to my notepad and use my pen tool, so what is the power half? So if I use power half on a number like 100, it basically means that we are using this is also expressed as 2 root the number of 100, or is also represented as root, because 2 is the default, so it's root 100. So this is the representation. If for example, if I take the number 25 and say it's to the power 1 by 3, let's say 1 by 3, it means it's basically a representation of 3 root 125. So this is the concept of root and how it's represented. So if I focus on this, the problem 4a, which we have to find the root, basically find the root of 100. So what is the root of 100? The root of 100 is 10, because if we square 10, then we get if we square 10, we get 100. So if we do a root of 100 or 2 root of 100, we should get back 10. So this is the solution to the first part. So if we focus on the second part, which is 4b, it says you have to find the value of 125 to the power 2 by 3. So this is slightly tricky. So let's say the number 125. So 125 to the power 2 by 3 basically means it can also be represented as 125 to the power 1 by 3, and if I do a square of this, because if we multiply powers, it's 1 by 3 multiplied by 2 is 2 by 3. So we can also write in this way. So what is the value of 125 to the power 1 by 3? So the value of 125 to the power 1 by 3 is, if we multiply 5 with 5 and 5 again, thrice, so 5 cube yields 125, right? So 125 to the power 1/3 will yield back 5. So this value is basically 5. So this representation is actually 5 square, which is what? 5 multiplied by 5, or 25. So this is the answer. If I look at problem number 6, which has 3 parts, which is a slightly different problem. So problem 6 has 3 parts: 6a, 6b, and 6c. So if I focus on 6a first, it gives me a table with information about the planets, the distance from Earth, and mass. So you have to write down the name of the planet with the greatest mass. Which planet out of these 8 has the greatest mass? So if I open my notepad and use my pen tool, as you can see, just from normal glance, the mass, if you look at the powers, which has the greatest powers? 27. 10 to the power 27 is the greatest power, followed by 10 to the power 26. Neptune and Saturn has 10 to the power 26. So the others can be immediately rejected because they are far away. So we can compare Jupiter, Neptune, and Saturn, these 3. So if I write down the masses of Jupiter, Neptune, and Saturn, so let's start with Jupiter. Jupiter has a mass of 1.898 into 10 to the power 27. So Jupiter has a mass of what? 1.898 into 10 to the power 27. Okay, multiplied by 10 to the power 27. So Neptune has a mass of 1.024 into 10 to the power 26. Neptune has a mass of 1.024 into 10 to the power 26. Okay, and then Saturn has a mass of 5.68 into 10 to the power 26. So Saturn has a mass of 5.68 into 10 to the power 26. Now which one of this has the greatest mass? So if you look at Jupiter, if you look at this power 20 to the power 27, this can be represented as what? 10 multiplied by 10 to the power 26, or 10 to the power 1 multiplied by 10 to the power 26. So if I multiply 10 with 1.898 and I equate the powers 10 to the power 26, and in terms of Neptune and Saturn is also 10 to the power 26. So if I multiply 1.8 with 10, we get what? 18.98, and the power is 10 to the power 26. Okay, so in terms of Neptune, we get what? 1.024, and in terms of Saturn, we get 5.68. So we can now clearly see that Jupiter has the greatest mass. So if I focus on problem number, the second part, which is 6b, you have to find the difference between the mass of Venus and the mass of Mercury. So the mass of Venus, let's say the mass of Venus is 4. The mass of Venus is what? 4.869 into 10 to the power what? 24. 10 to the power 24. And what is the mass of Mercury? What is the mass of Mercury? 3.302 into 10 to the power 23. So the mass of Mercury is 3.302 into 10 to the power 23. So you have to find the difference. So as you can see, 10 to the power 24 can be represented as what? It can be represented as 10 multiplied by 10 to the power 23. So if we multiply 10 with 4.869, we get what? Both powers have 23, so we can match then. So if we multiply 10 with 4.8, we get 48.69. into 10 to the power minus 20, 10 to the power 23, and in here in the case of mercury we get 3.3. so we can see the difference is somewhere around 45.3 or 4, something like that. So this is the difference between the mass of Venus and Mercury. So if I look at the third part of the problem, 6c, it says Nishat says that Neptune is over 100 times further away from the Earth than Venus is. So if you look at the distance from Earth for Neptune
and Venus, for Neptune is 4.35 into 10 to the power 9. So for Neptune, the distance from Earth is 4.35 multiplied by 10 to the power 9, and for Venus is 4.14 into 10 to the power 7. So for Venus it's 4.14 into 10 to the power 7. So we can similarly do the same thing. We can do
for 10 to the power 9 it can be expressed as 10 square multiplied by 10 to the power 7. So if I multiply 10 square or 100 with 4.35, so we can equate both parts the same way. So if I multiply, then we get what? 4.35 multiplied by 100 is around 435, right? And multiplied by 10 to the power 7, and in this case we get 4.14. So you can clearly see that 435 is over 100 times away from than 4.14. So Neptune is more than 100 or almost close to 100 times away from the Earth as Venus is. So Nishat is actually right. By now you have already got an idea of how I approach to solving the concepts or the problems regarding the concepts of powers, roots and standard forms. In the next video I'll also focus on some more problems regarding these concepts. So stay tuned for that.